This is the last video we're going to do on inverses. And this is actually the most sophisticated one of them all. So let's just start with this example. So now this is example number 5. And what I'm going to do is this time, instead of just having one function, I'm going to have two functions. So I'm going to have, say, f of x, and that's going to be 2x minus 4. And then I'm going to have also another function, which is g of x, and that's going to equal to x plus 3. All right? So question A, and this is actually going to be a multi-part question. So we'll go start with part A. Part A says, find f inverse of x. Okay, so find f inverse of x. So this is our f of x, and remember, step 1 to find an inverse function is we have to write everything in terms of a y and x. So it's equal to y. Oh, let me just do this in green. So that looks like we're doing an answer. So the first step is y equals 2x minus 4. I literally just rewrote that and replaced the f of x with y. To find the inverse, we have to switch the x and y. So x equals 2y minus 4. Next, we have to solve for y. So first we have to get rid of the negative 4. So we have to add 4 on both sides. So it's x plus 4 is equal to 2y. And then you divide by 2 on both sides to isolate the y. So y equals x plus 4 divided by 2. Remember, that's not our final step. Our final step is to rewrite the y in terms of the f inverse. So now our final step is the inverse function is equal to x plus 4 divided by 2. And there we go. All right? So that was part A, to find f inverse. And I hopefully that was straightforward. Let's do the next part. The next part, part B, says find f inverse of 6. All right? So in order to find f inverse of 6, the first thing that we need is the inverse function itself. But we just found that. We found the inverse function right here. So if we want to find f inverse of 6, we literally have to replace this x with the number 6. And there we go. And remember, we can't use the original function f because that's just the original function. It's not the inverse function. This right here is the inverse function. So let's go to this. So I'm going to scroll up just a little bit. So our inverse function, I'm just going to rewrite our inverse function here. Oops. Once again, let me put that in green. So our inverse function is that this is our general inverse function, which is equal to x plus 4 divided by 2. So our specific function, f inverse of 6, is equal to, we're going to replace this by 6. So that's also going to be replaced by 6. So it's 6 plus 4 divided by 2. So that's equal to 10 divided by 2, which is equal to 5. And we're done. So this is our answer for f inverse of 6. Finally, the last question that I want to ask is this. And it's actually going to involve composition of functions, something that we've studied already. So the question says, find f inverse of g of 9. G of 9. All right? So even though we haven't seen how to do this with f inverse, we can do this using the principles we've already understood from composition of functions. So in order to do this, we have to first rewrite what this means in proper notation. So if I had to rewrite this, f inverse goes on the outside, open bracket, then I put g, and then I put open bracket, and then I put 9 over here. All right? So if you remember when we did composition of functions, first we have to figure out what's on the inside and then go to the outside. So the first thing we have to do is figure out what is g of 9. So it's f inverse of, okay, so let's look at what is g of x. I've forgotten what g of x is, but let's go right to the very top, and there we have it. G of x is equal to x plus 3. So whatever number is here should go over there. So if I'm looking for g of 9, should be equal to 9 plus 3. So let's do that. Let me go scroll down. So this is equal to something plus 3, and that something happens to be 9. So if I rewrite this, it's f inverse of 12. Now, we're trying to find f inverse of 12. Well, in order to find f inverse of 12, we need to figure out what f inverse is. Well, we already know what f inverse is because we figured that out right here in part A. F inverse is equal to x plus 4 divided by 2. So whatever I write for that x, I'm going to have to replace it over here. So if I'm looking for 12 over here, this has to be 12 as well. So in other words, this is simply equal to something plus 4 divided by 2, and that something happens to be 12. And now let's do this. What's 12 plus 4? Well, that's 16 divided by 2. And what's 16 divided by 2 is equal to 8. All right? Well, I hope you understood this sophisticated example. All we're doing here is always, if you're ever trying to figure out the inverse of a specific number, make sure you have the inverse function done first, like we already had in part A. And if I didn't ask you part A, you would have to figure out what the inverse function was first before you can plug in the 6. So once you have the inverse function, plug in that number, and there you get your final answer. And then finally at the end, when we're dealing with composition of functions, it's basically something that you haven't seen before, but it's the same idea. All you're doing is you're just going inside, you figure that out, and then once you've figured out something in terms of the inverse function, plug that into the inverse function, and you're done. All right? Great, and I'll see you in the next set of videos.